Sometimes you will need to use your calculator to work out the answer to a trigonometric ratio. So in the first example here, we're given sine of 23. So we can just put that into the calculator, sine 23, and we can get our answer to 2 decimal places. That will be 0,39. For the second one, we could be given two angles in the same bracket. That's fine. You can just put that into your calculator as you see it, 21 plus 43, and we get an answer of 0,44 rounded off to 2 decimal places. These answers will have no units as they are ratios. In this type of question, you can be asked to find the angle if you are given the ratio. So as you can see here, we do not know the value of theta, and that is the value that we want to isolate on the left-hand side. In order to do this, we use a special function called the inverse of cos, which will essentially cancel out the cos on the left-hand side and leave us with theta, and then we need to do that on the right-hand side as well to keep the equation balanced. So then we end up with a situation where we don't have cos on the left anymore, and then on our calculator we can press the shift button and cos, and then that will give us an angle of 60 degrees for theta. It is important to understand that cos to the -1 does not mean 1 over cos. These two things are different. Cos to the -1 is an inverse operation which we use to isolate the theta variable when we're doing this equation. 1 over cos theta is actually equal to sec theta, which is the reciprocal ratio of cos. Let's have a look at these two examples and see why they're different. So in this first example, we have a 2 multiplied by cos theta, and in the second example, we have cos 2 theta, where the 2 is multiplied only by the theta. This means that when we rearrange the equation to make theta the subject of the formula, we're going to do it in a slightly different order. For the first one, what we can do is divide both sides by 2, and then once we've done that, we'll end up cancelling out the 2 on the left, and we can then work that out on the right, or you can leave it as it is, and we can do that at the final step. And then we're going to do arc cos on both sides, which is going to isolate theta, and on our calculator, we'll press the shift button and do 0,3 over 2. And that will give a value of 81,37 degrees. So that's what theta is equal to in this equation. But if we have a look at the second equation with the 2 next to the theta here, we actually do not touch this until the very end. So what we first do is arc cos on both sides. So we end up isolating 2 theta and pressing the shift cos button on for the right-hand side. And then we can divide everything through by 2. So this is going to be shift cos 0,3 all over 2. And then we can get that solution. That will give an answer of 36,27 degrees. So you can see that these two things are completely different. This example is a multi-step question. You can see that we have theta here, but there are many other things that we need to do first. So we need to know which ones we start with. So we always look at the thing that is furthest away from theta, and we only ever do what's in the bracket at the end. So the first thing we want to do is we want to subtract 2 from both sides. So I'm just going to write down every step as we go along so that you can see exactly what we're doing. So we're going to subtract 2, so 87 minus 2 is going to be 85. Then after that, we can now do the arc tan. So we're going to be left on the left-hand side with 3 theta plus 10 degrees is equal to arc tan, or we press the shift button on our calculator, tan, and then 85. Now we can start moving over the other numbers. So the first one we can do is we can subtract 10 from both sides. So that's going to give me 3 theta is equal to arc tan of 85 minus 10. Once we've done that, we can divide by 3 on both sides, and then we can just put this part in the right-hand side straight into the calculator to get the final solution. (26,44 degrees). So to take note for these types of questions, you want to leave the bracket to last, and do everything that's furthest away from theta before you actually finally isolate theta, and that will then give you to the correct solution.